Hello, my name is Yuanhui, Zhang, University of Illinois. I'm sorry I can't be here. This is my narratives for a few slides. I think the agriculture's new opportunities lies in bioenergy and the environment. Based on the biogenic hypothesis, so far all fossil fuels found on Earth, petroleum including oil, shale, and tar sand, natural gas, and coal, based on the biogenic hypothesis, are formed through processes of thermochemical conversion from a biomass buried underneath the ground and subjected to millions of years of high temperature and high pressure. We are able to mimicking nature's millions of years process, successfully converted swine manure, algae, and other bio waste into crude oil in minutes using hydrothermal liquefaction, a type of the thermochemical conversion process technology, and in 10 to 14 minutes. This is a roadmap of a so-called environment enhancing energy roadmap. First, we separated the biosolid from the bio-waste water, and the solid is through this hydrothermal liquefaction converted into the crude oil, and the liquid sent to the algae pond, and together with the post-HTL liquid and nutrient to produce a lot of more algae biomass, and the algae feed back into the HTL reactor to produce more crude oil. During this process, the oil is contained carbon and hydrogen, and yet the nutrient, including the nitrogen and the phosphorus, and feed back and recycled during this process for the algae growing. We will demonstrate later on this recycling process serves like an amplifier to magnify the biomass production. We will use a case study shortly later to demonstrate how this can produce substantial amounts of the biomass and therefore crude oil, and clean the wastewater and capture the carbon, and to produce the biofuel at the same time, clean the wastewater, capture carbon, and improve our environment. This is the continuous reactors we developed in our lab. We are also able to demonstrate to convert all kinds of the algae, including microalgae, macroalgae, and bio-waste, and including bacteria. Those algae not necessary to use higher lipid. Initial lipid content and HTL oil conversion efficiency showed in these graphs, and we achieved the energy ratio of 3 to 11 to 1, which means we input one part of the energy, and we can obtain crude oil containing 3 to 11 fold of energy. So this is a paradigm shift from the extracting oil from algae, rather than what we are doing is converting the biomass into the crude oil. This shows quickly a couple of things. The nitrogen uptake or reduction in the aqueous in the post-HTL wastewater, and nitrogen reduction in the crude oil. As the temperature increased, more nitrogen can be recovered in the aqueous product. And nitrogen recovery of the biocrude oil also increased, mainly due to the increase of its oil yield. We demonstrated here about 70% of nitrogen can be retained in the aqueous phase after the hydrothermal liquefaction, and therefore can be reused for algae growing. These also demonstrate our capabilities in this process for the phosphorus recovery. It's more than 85% of phosphorus can be recovered, and also the total nitrogen recovered during this process is 80%, more than 80%. Based on the National Algae Biofuel Technology Roadmap in 2010, is the quote here: inevitably, wastewater treatment and recycling must be incorporated with algae biofuel production. Why? because nutrient recycling would be needed, since wastewater flows in the United States are insufficient to support large-scale algae production on the basis of a single use of nutrient. So this is our case study. Let's take a 100 ton per day wastewater treatment plant, which is about the equivalent of 6,000 hog farm based on the volatile solid, nitrogen, and carbon content. So in this process, let's say it takes 1,000 ton per day effluent, and it is containing about 4 suspended solid and 3.6 ton of carbon and 625 kilograms of nitrogen. During this process, again, this is the repetition of the environmental enhancing energy roadmap. We converted it into the crude oil and recycling the nutrient and clean the water and amplify the biomass. So let's see next. Of those effluent, total suspended solid, and we can magnify this biomass into about 10-fold, into 37.9 tons. This will produce 14.5 tons using our hydrothermal liquefaction process. And look at the numbers. Initially, we only have 4 tons of solid, and then we have almost 38 tons of additional biomass and produce this much of crude oil, and we captured 9.1 tons of carbon from atmosphere. So this case study demonstrated how this environment enhancing energy be able to capture the carbon, recycle the nutrient, and produce a substantial amount of the biomass. And in the meantime, we can produce some large amounts of the crude oil and clean our wastewater. Thank you.